Hello and welcome to the GPL Technologies webinar. We are featuring Arista today, one of our top partners, and I've organized for Arista to speak with us today, and they will be speaking about 4K and beyond. Is your network ready? Just to tell you a little bit about GPL Technologies, we are a company where we do customized IT services for creatives specializing in the media and entertainment industries. We design, implement, and support innovative solutions that are tailored to your business goals and needs. And we use great partners like Arista to integrate and facilitate making your post-production studios, your rendering farms, and workstations. Just to let you know some of our services, we do things like managed services where we scale your creative power with managed IT support. We do rentals, and we call this hardware as a service. That division is called VFX now. We basically have hardware on demand plus the engineering support. We do infrastructure solutions where we do the consulting, infrastructure design, and deployment of services. And additionally, we provide staffing, technical staffing, and this division is called Breed. And the type of staffing we do is direct placement, contract staffing, and contract to hire. We have a lot of partners, a lot of fantastic partners that we work with, and we integrate them to come up with the best design for your company. One of those great partners is Arista. And like I said, Arista will be talking about 4K and beyond and seeing if your network is ready. And the webinar will be on the latest cloud networking solutions from Arista, hosted by Arista's media and entertainment specialist. We have Robert and Russ, who both have many years of experience that will be telling you all about Arista's offerings.
Thank you, Melissa. This is Russ Giles. I'm the technical account manager, a major account manager for Arista. A quick, brief summary on who Arista is. We are a publicly traded company, number 2 in the data center switching market, number 1 in the media and entertainment market, and we're growing at about 30% a year. We are a profitable company. And we are here to help our customers solve their problems when it comes to network and broadcast and all the things that media entertainment have. So we're going to help you get packets from point A to point B as fast as possible.
Right, you are, Russ, and we're kind of glad to be here, especially with GPL as a great partner. We've got some interesting things to kind of show you and talk about. We didn't want this to just be a PowerPoint slide deck that you would just look at for the webinar here, but also something to actually promote constructive discussion and dialogue. We would love for this to be open. Feel free to put anything into the chat window that you have a question on. We have a couple of breaks throughout the conversation that we'll actually do some Q&A on. But we want to make this a very lively conversation. But to start off with, we want to put some things on the screen that are kind of top of mind, things that we've been talking about to many customers, partners, and industry analysts about. And it ranges everything from the broadcast to file-based workflow to all the way to security and compliance. For the broadcasters, it's how to move to IP. It's about taking the bespoke network, your SDI infrastructure, the thing that you've known and loved for the last 15 years, and moving that into an agile infrastructure. And the transition to IP can be very scary for some people because they have to change their people, process, and tools. How much retooling can I afford? What am I going to get out of retooling? Is IP really the direction for me? And looking at what the IT guys are doing versus what my needs are, I need a no-drop environment. I need something that's always on. Am I going to take and adopt what the IT guys are doing, or am I going to invent something net new? And what does that mean for me as a business sense to take my current properties I currently have from a broadcast perspective and maybe do second screen or over the top? How does it change my business? And then looking at the file-based workflow, because to have a broadcaster, you actually have to have content. So the file-based workflow, the post-production, the rendering, and graphics guys really are stepping up here. And for the file-based workflow guys, the guys that are actually creating the content for the people to broadcast, they have their own challenges as well. Am I going to stick with fiber channel? Do I need fiber channel? How fast is the storage system? How much storage do I need over time? And that's something we're really going to dig into. And then from a networking perspective, how do I adopt a 4K type of infrastructure? Do I need to be ready for a 6K and 8K? How much throughput do I need? How big is big for these guys, both in storage and networking? And then speed. It's all about speed to product. It's about reducing the latency and time. It's about having product and content that I can edit right away. The time to ingest has to be decreased in order for me to start editing on that. Now, sure, you're going to start working on a proxy maybe out in the field, but how do I bring that in quickly put my media asset management on there, put it into my systems, and then figure out who needs to do it, and then start editing very, very quickly. So the time to market is decreasing. We're seeing this a lot with the long tail type solutions of product that are coming out. There's a lot more product being created, and the time to create that product is starting to reduce. So what can we do from a networking perspective to help you reduce those time cycles? And then importantly, and kind of a foundation of all this, is how do you do this in a secure fashion? Security, risk, and compliance are a foundation to what we're doing from an industry perspective, but also protecting your assets, whether you're working on your own assets or for somebody else. So there's a compliance either from the MPA or other studios, and then also if you're working with the European types, the S4C for compliance for both networking and storage. And then combining those from a live production and post-production and also back office services, can I actually put all three of those networks on one common platform? All these are very good questions that people have asked us over the course of the last year or so. So let's look at where the industry is going and what we're doing. Arista is not just participating as an industry analyst, if you will, but also actually writing standards. There's a joint task force for network management in the market technology group that actually makes sure these standards work together. It's one thing to have a standard, but it's another thing to actually make sure that it works for you and for customers. Is what we just built for a standards industry even applicable to you as a customer? And then how does that actually work? And is it easy to absorb and to train on and to use? But what we're talking about from a broadcast industry is how do I transition to support a 4K infrastructure? They just upgraded to HD. Well, now how do I upgrade to support 4K or 6K or even 8K type workloads? Do I need to do that with inside my bespoke network and just replace things with SDI, or should I be looking at IP? So we're looking at this from an industry stand perspective and how things move. Arista is definitely participating in all these standards from and you can see the cornucopia of acronyms here. We have the VSF, which we just talked about, the Video Services Forum. We have the Society of Motion Picture Television Engineers. We have the Advanced Media Workflow Association, also called AMWA. We have AIMS as well. We have the Avenue Alliance. All these things are different consortia and industry standards that Arista actually participate in. Why do we participate? It's because Arista knows IP. We know how to make IP work, both in a cloud type perspective and also for the media and broadcast space. We think building the standards applicable to what the customer's needs are is more important than just coming up with a standard that may not be applicable. For example, we're working on SDN type services. What are the right APIs to make sure that SDN works for media and entertainment? And what does that really mean? What's interesting about this is people are adopting our technology and winning awards. For example, Thomas Edwards, who's the VP of Engineering and Development over at Fox Network Engineering Operations, has just won an award. He's going to get a SMPTE award for co-writing an article with Andy Bechtolsheim, who's one of our founders. And it was all about, and this was written a few years ago, all about converging to IP, but more importantly, how are you going to actually do frame-accurate switching in the network? So we came up with a solution set to do this. Now, this is kind of nascent now because we all know how to do this. We either do it at the source, the destination, or the network, frame-accurate switching, but this is all new technology to people 3 years ago. So these are the thought leaders that we're working with and actually wanting to work with that are helping us to form new products. In terms of standards, the applicability to Arista is that we're taking these off-the-shelf standards from IEEE and AES from an audio perspective or IETF, and we're actually building new protocols around this. We're taking our standard RTP packet, which is out of the IETF, and we're using that from a SMPTE standard to define what media streams look like. Do we need to use jumbo frames? Should we have smaller packets? What does it mean to do interleaving? Do we have to have QoS? Is QoS a bad thing? What do we do from a network property perspective to make sure the packets are actually working? What about congestion control? If I lose a packet, what happens then? How do I do failover? And then the VSF, which we talked about before, is to making sure that these standards actually work together. It's one thing to understand a standard from my perspective, and you understand the standard from your perspective. It's a whole different thing to make sure that it actually works together and to make sure that the consumer can really use this. And that's where the interoperability testing that the VSF is a foundation for comes together. Out of this also are new and interesting ideas, like, for example, what's coming out of the NWAS group out of the BBC. This is a registration and discovery service. So imagine you've got your Grass Valley camera, you plug it in, and it automatically registers to the network. It identifies itself, it identifies the codecs, it identifies its capabilities. And we can, from a networking perspective, actually put policy on there. You're supposed to be on this VLAN. Oh, by the way, you're in Studio 2 and you need to be connected to Studio 3. We need to not allow you onto the network, right? So those types of things. You can almost attribute this back to what we have for the Bonjour protocol in the Mac environment, where you plug your printer into the network and you can self-discover it. We're using those same techniques, if you will, from a networking construct to make sure that things are very dynamic. So, for example, if you plug an Avid system in or a rendering system in, we would know about that, and you could use that and consume that as needed. And you could put policies around that also. So that goes back to the governance, risk, and compliance. So these are the things that we're working with the different standards bodies to actually develop. We've even built code around this. It's very easy because we're a very agile platform, Arista does, to actually build code very quickly. So you can actually put your own extensions onto the Arista switch as you need, quite frankly. So we want to allow that creative experience. So in our case, in the networking environment, we usually talk about LLDP. We do a show LLDP neighbor. Where's the switch at? What port is it? What version of code are you running? Wouldn't it be really cool to do something similar, looking at the registry where things have registered to, and say, and by the way, here's my capabilities, here's the port, here's the QoS values, and dynamically control that. And those are the interesting things that we're coming to come out with that you'll see here in the next couple of months. So it's really interesting from a paradigm shift perspective. We're becoming more agile. We're providing more protocols, more SDN type services. So we really have this big IT velocity challenge. When we polled pretty much probably some of the people that are on the call here, what are your biggest issues? And the biggest issues was agility and also cost. Drive down the cost for me, please. Get me something that actually works, that I don't have to worry about, that I can sleep at night. And by the way, I want to be able to go from a 2K environment to 4K to 5K to 8K without even thinking about it. I want to be network ready for all these different formats that are going to come out my way. I had a producer that actually asked me the other day, can we actually just shoot in 6K and just leave it that way and we'll render in 4K? Absolutely. What do we need to do that? The same switches you're using today, which is kind of cool. So should we be looking at this from an agility perspective? Absolutely. We want to be in an enablement. And also in an enablement, it's all about more content, more options, more people, more internet, more eyeballs. So as people get away from the primary screen, as we grew up in primary screen, and the kids these days are saying, well, their primary screen is cord cutters or the iPad, their desktop or something, or even Hulu or something else, we want to actually reach all those different people. So it's some of you probably participated in this, and this is kind of an old statistic, but I want to show you how things have progressed just in the last couple of years. In 2014, the FIFA World Cup in Brazil had 64 tournaments. Each one of those had 34 cameras. That's a lot of streaming. That's a lot of content that can be had. Why should I limit that just to whatever the director says? Why don't I allow the people in the audience, the second screen users, if you will, to be able to zoom in on a particular player, to select what they want? And then I can monetize that so they can actually have a premium or a gold service or sell different services. And since they just logged in, to allow that particular service, I'll do target advertisement to them. I'll sell advertisement a little bit differently. So now I'm able to monetize this because I'm not doing it over the top, but I'm actually using the same assets I had available to me during the live broadcast. So these are the things that people are looking at to change their business, to actually get more revenue off the existing properties that they're already either capturing or rendering. Another one that's interesting to me is everybody wants to be a star. All the kids want to be a star. In Burbank, we have these, every weekend we have these fandom things at some of the local houses where you see all these YouTube kids out there, the 11 to 14-year-olds that line up to see the new YouTube phenom that's around. So these are interesting things that are occurring. And now there's even shows, not just for like the Food Network, but to watch people eat. Who would have thought of that? I probably wouldn't watch somebody eating, but there are people that want to do that. So there's interesting paradigms for people that want to get into a different way of viewing or their own viewing aspects. So this is where the different content comes into play. More importantly, is everything is being digitized. We're getting away from the analog world. The analog world was I watched something and I got whatever that was there. I had 13 channels on TV for VHF and UHF, and what was on there, that's what I got. But in the new digital paradigm, the cord cutters, which you can think like the 18 to 24-year-olds, they're not likely to invest anything into TV. They're going to go over the top. And so pay TV services as we know it are shifting and changing. These are all things that you know and you're building content for, which is great. And also the number of properties are increasing linearly as well. And we think there's going to be an exponential growth in number of properties in development. But what I really want to know, and maybe this will be a poll, and Melissa, maybe we should put this in as a poll, is you look at that bottom right from the PricewaterhouseCoopers here, is that 29% of you are actually watching TV while you're commuting. So we should have put a poll here. Raise your hand if you've ever done this, but I don't want to call anybody out. But it's true that you're always on, you're always connected now to TV and different services. Okay, so it's an interesting shift. Also, what's interesting is you just follow the money. The compounded annual growth rate is 22% for over-the-top services versus anything that the broadcasters had prior. So if you're looking at a Bell Canada or a Charter or a Time Warner, they're moving to more over-the-top type of solution sets. They want to actually get to the Hulus and Rokus and Amazons of the world and get their content on there. They want to actually partner with these other companies because that's where the money is. That's where the growth is. So the money shows that. So going from a bespoke network, the SDI environment, over to more of a data center, agile, VMware environment is where people are actually moving towards, at least from a broadcaster standpoint and also from a rendering standpoint. We're seeing, for example, rendering and editing in the cloud. Go to Amazon Web Services and do it all there. Is it real time? No, but can you do rendering and then bring it back? Yes. So you can do over the top type rendering, if you will, or cloud-based rendering and then bring it back. So using the facilities that are available to you both on-prem and off-prem is the new paradigm. And speaking about this movement from SDI to Ethernet, you can even use, by the way, the Arista Ethernet switch as an SDI switch. So you don't need a big Evertz EXE system anymore. You could actually take your existing Ethernet switch, put these little SDI devices in there from Embryonics, for example, and go SDI to IP, or even do TCO compression, or any type of IP to SDI, if you will. So now as you migrate from SDI, or need some amount of SDI, you can actually have a hybrid approach to this. This gives you flexibility. It affords you the migration capability. It affords you that ability to do whatever you want, mix and match, and also scale up and scale down at will. So I want to stop there, slow down a bit, and see if our number of attendees have actually dropped, if they've gone up, and if we have any questions.
The number of attendees has not dropped. It is increasing as we go along, and I think everyone is definitely interested in what you have to say. I've just got Ergi just saying we need faster, everything faster, and also pointing out that apparently in California they've just passed a bill where it's illegal to watch TV in your car.
Good to know. Yes, that's interesting. So Governor Brown's going to regulate that, and also bookstores as well. It's awesome. I love it.
Yep.
Good old Governor Brown. Thanks for that, by the way. Okay, so anyway, back to focus. Okay, so why Arista? If you follow the Arista, along the way, we've actually started off with high frequency trading. So in that, Russ, when you do your $10 million trade on Friday, when stock's going up, you want to make sure that not only did the trade occur, but it occurred at a specific time. So it has to be a no-drop environment, very, very P2P, time accurate, and at scale. So that's kind of our lineage. Arista grew up in that high-frequency trading. And then we moved into the cloud titans, the automation, if you will. So we had to have a box that was not only good at what it did of passing packets, doing standard routing protocols, but it had to be open. If somebody like a Microsoft or somebody else actually wanted to write code and put it on there and add their own automation toolkits, we could do that, and we allow them to do that, and we encourage that, by the way, and I'll give you a couple examples. But more importantly, and this is true for the broadcast and media environment, is no drop, virtual output queues, and big buffers. And I'll go into more for the big buffers in just a bit, but no drop. If I drop a packet, if it's a media packet, what does that mean? That means somebody has to retransmit. And that's bad because that puts the pressure back on the end systems. I'd rather have a network that's more efficient than one that just had a bunch of speeds and feeds and drop packet all over the place. And by the way, it has to be very time accurate, especially for the broadcast industry, because we only have 4.7 microseconds to actually do a switch. So it has to be very, very specific, very, very time accurate. So we have to know the latency through the switch and when these transitions can occur. So we're actually building products that's not just relative to media and entertainment and high frequency trading, but we're actually taking feedback from all these different groups, these different verticals to build better products, to be more open, to be more time accurate, to be more scalable. And if you double click into this just a bit more, you can see some of the things we're doing. And this is not the huge list. It's just kind of a minor list, if you will. So we actually do PTP, the new SMPTE 2059-2, which is a very tight time scale at scale. So we can take one of our biggest switches, the modular switches, which is like the 7512R, and actually do this PTP at scale, multicast at scale. You can also do AVB, which is another solution set for media and entertainment for actually lossless networking. It's a bandwidth reservation mechanism. So it's all about lossless IP. It's also about automation. We want to give people the toolkits. We're a Linux platform to start off with. We have open API capabilities. You can load your own code on there if you want to, Docker, VM, or something else, and do interesting things with them, and I'll give you some examples. But more importantly, from an automation perspective, we want you to play, but we don't want you to get in trouble. When there is an issue, we want you to be able to control the services on there. We want you to get telemetry information out of there. We want you to be able to even patch the system and not take the system down. We actually think doing updates, as in the old ways of putting new code on and bounce to the box, is way archaic. That's back to the 1970s, right? That's the old way that we should patch on the fly like new modern operating systems do. And then more importantly, and all that is if it doesn't work, if it's not scalable, if I can't do cool things with it, but also go home at night and actually know that this is going to work, who cares? So it's about the architecture we're building on. And if you go out to YouTube and you look for Ken Duda's video, Ken Duda is our CTO, he says it best. An Arista architecture enables you to move faster with software that has greater stability. The bug is in their architecture. We started off with something of a new paradigm. We had to start over. We don't want you to live in fear of bugs. We want you to move towards new features. That's the way we kind of work, live, and breathe. We want you to be able to put services on there. So let me give you an example. Let's say that there's some kid, and I'll just make this up. This is not to imply that this actually happened. Some kid in Prague, 23-year-old kid, just happened to come up with an SSH vulnerability. Okay, great. We run SSH as a service. How about just patching SSH, not rebooting the box, and just putting that service back in? Or if we have a race condition or some type of issue with one process, how about just patching that process? Or more importantly, if you have something you want to put on the box and you want to build your process, you can do that too. We have something called EOS SDK. You can write it in C, Python, Chef, all kinds of different things. You can put that on there. And you can also get telemetry information out. You can do Go programming streaming to get all the statistics off the box. We think SNMP polling is the old way of doing things. Looking at things in 5-minute averages is the old way. You want to get microsecond information about what's happening on the box and the flows, you can get that on the box. We also have deep inspection capabilities from a buffer perspective. And then also we have Puppet Chef, Ansible, and the whole plethora of type of integrations for automation and configuration. So you can truly do a zero-touch replacement, zero-touch installation of your switches from day one. So this is taking a whole different way of looking at the network. We're talking about a strategy, or as George Bush put, strategery. Now, having a plan, even if it's a dangerous plan, is better than having no plan at all. But I think that in terms of what we're talking about with Albert Einstein is fail and fail fast. That's how we learn. We learn when we actually make problems. So let's build up a little lab. Let's figure out what to do. Let's figure out what the right automation is, figure out what the cool tools are, and let's do this development, this agile process over and over again. And we encourage people to do that. In fact, we even have white papers on how to do this, automation and extensibility. We've got white papers on how to do that. And what Gartner's actually saying is that everybody's going to have this bimodal structure for quite a long time. You're going to have the change control Thursday, stable group on the left, and you're going to have this very agile environment that's going to invest in new technologies, new toolkits, and new agility type functions, and that's going to be that's the new business paradigm, is investing in that new. And we want you to play around with these switches. In fact, we don't want you to just think about these as switches as hardware, as discrete components. We want you to think about these as software solution sets throughout your network. What can you do with this? Hey, what if I was actually looking at a stream or a data rate and looking inside the packet to see what it was doing dynamically? That's a great idea. How can we do that? What are the toolkits we can do to actually dynamically configure the network? Like I was talking about when the camera comes on in Studio 3 and it should be in Studio 2, how can I alert to somebody that it's in the wrong place because my schedule all system says, I'm going to put this live here at 2 o'clock. Is it ready to go? Okay, so those are the types of things we're working with some of the big broadcasters on, but also for the post-production guys, what can we do from an automation perspective to maybe give more bandwidth for Aspera at certain points in time or for particular properties than something else? Should they go into Aspera itself and do the scheduling there, or can the network be triggered by the end device? So those are the things we're looking through. And then also when we're talking about patching and updates, you can actually go to, and I encourage you to go to the Arista website and take a look at the minor number of vulnerabilities that we've had. And we encourage people to patch on the fly. Literally, we tell people patch on the fly. Don't load new code and reboot. That's the old way of doing things. We really think that this is adopting the new paradigms are the way that people have to start working. And it's quite frankly, it's almost a scary thing from a networking perspective, because the networking guys are used to patch, reboot, and go. They're not used to this Unix type of RPM function. And I'll slow down a little bit, but I want to get through this next section and get to the cool stuff, which is the big buffer stuff, which is really interesting. Is we also do integration with Lawo, Nevion, Magic, Grass Valley, etc., Harmonic, and we do interesting integration with these guys because they're used to kind of the SDI switching. And this was actually proven out at Rio here. By the way, Arista was the switch, the network vendor of choice across the entire environment. We passed more packets in that location than I think Amazon does in a day. So the integration that afforded us to do this was actually through Lawo and Imagine. We have deep packet integration, so they could actually do hitless switching on the fly. So it's an SDK type of function. They tuned into the SDA, and they basically did a hitless switch frame to frame. So that's the broadcasting industry. What I want to do is I want to change that. And so if you don't have something to broadcast, if you don't have properties, you don't have content, what good is it? I need to create content. So I want to switch over to the content and IP-based workflow. But before I do, Melissa, I want to see, and Russ, to see if there's any questions out there so far.
I do have a question from Ergi, and that is, what are some of the lower end specs of the Arista devices that support your claims?
Good, very good. I will get into that in just a bit, but if you permit me just a few slides, as you can see, it's just coming up in a couple of slides. Okay, very good question, very good leading question. And by the way, the things that are in the slide, there's more. I'm going to give you a multicast scale, ARP scale, routing scale, things like that. Just as a side note, the 7280R series we're going to show you in just a bit, people are using those not only for just your standard data center switch, but also internet edge. So you can actually do full scalability internet edge-wise as well. So it's almost a Swiss Army knife, which is kind of cool. So getting back to kind of the file-based workflow, what we've seen is a big challenge in terms of networking. People put a standard size switch in there, and then they'll try to beef it up by doing interesting things like putting iWarp or accelerating the storage, or even doing TCP offload from an endpoint perspective. And they'll put either the SolarFlare or the Chelseos or Miracom or one of those guys in there, and they'll find out, hey, I'm still not going fast enough. And what we found is that when people are using the lower end switches, even though they're from a tier 1 manufacturer, they're not built for the job that they're intended to do. So when we're talking about 4K type workflows, it's not about bandwidth, it's more about throughput. It's about getting from point A to point B without dropping a packet. It's about completing the flow. It's not just about having bandwidth that then gets dropped on the floor. And if you look at 4K, for example, and I think everybody's familiar with the Aja data rate calculator, you go into custom mode, you can get the 4K values. So for 4K at 60 frames per second, ProRes 4.2, so it's got the compression in it. We're talking about on a 1 second basis, because your storage-wise is 376 megabytes. So your storage is going to increase, pretty significantly. And I'll show you what some people are doing to get around that. But more importantly, the data rate from a transport perspective is going up as well. You talk about 376 megabytes from storage, and then you've got the streaming. So think about, as you're ingesting the content, how fast it needs to be. So there's a company called Pixspan that's out there that helps you reduce, and this is by no means a sales pitch. This is just trying to explain what people are doing to actually get more out of the pipes that they have. Is they'll do basically a lossless compression on the fly. So within the ingest system itself, the Avid systems or the ARI systems, they'll do an ingest and compression, a lossless compression, so that when it's saved on disk, it's actually compressed even more. So this is an interesting paradigm because people are trying to squeeze more bandwidth from point A to point B without upgrading the network. And I think that that's okay, but now you're having to buy more GPUs, right? You're having to buy more system capability at the edge than letting the network do what it's supposed to do, okay? So when we're talking about data rates, you guys all know this, you're on an exponential growth for storage and throughput. So we're talking just about 4K data rates. It's not just the 4K itself, it's the gamma values, it's the bit depth that we really care about. And of course, with more bit depth, you actually have more colors and more things we can do. This drives the visual effects guys crazy because it's like, what are we trying to do in terms of rendering here? But it's where we have to kind of think about. So if we're doing a phantom 4K, if you will, that's 3.5 gigabits per second. 1.5 terabits per hour. I mean, that's big throughput. So we're eating up a lot of drive space, disk space, and that causes the DI guys to go, okay, now how much space do I need just for the digital intermediate? Looking beyond the 4K, so what's 6K and 8K looking like? So we all know these values. We've seen these screens many times. Is we have to prepare for what 8K is going to do to us and what we can do with 4K, 6K, and 8K, right? A lot of the guys that I've working with are shooting at 6K because that's the size of the camera that they've purchased recently. Everybody wants to shoot in 8K if they can, but it's now the workflow associated with that. Are we just moving disk packs around? What does that mean to do disk packs movement from a media asset management perspective? Okay. So if you look at our switches themselves, and I'm gonna bash on our own cells, just kind of give you a differential, of what we have on our toolkit here. So our low latency 7050 SX switches, which is like the commodity switches for everybody else, we have those as well, has 12 megabytes of buffer. I think your USB drives that you have are more than 12 megabytes these days, by the way. But if you look at the latency that's occurred with this, you got a 550 nanosecond or 0.55 microsecond associated with that. If you look at the difference between a fiber-based system and a copper-based system, you see that there's a tax. So even though you might be moving from 1 gig to 10 gig, you can get actually a little bit more performance out of just going to fiber. Okay, so if you have a copper plant, great, go to 10 gig as quickly as possible, run. Okay, don't walk to 10 gig. But more importantly, you want to start thinking about going to fiber, because not only are you going to get the data rates, but you're going to be able to go to 25 gig using that same fiber, using the same multi-mode fiber. That means you can get even more throughput out of it with a fiber infrastructure, and then you can mix and match. Right? So that affords you a lot more when you start to move towards fiber. So this is one of the things that doesn't come up that often, but people need to understand that the switch itself is there to do certain functions, but then the transport may limit what you're trying to do. So you actually have what is a 5.5 difference between the 3 and the 550 nanoseconds. So choosing the right transport makes a little bit of difference too. Remember that 3 microseconds? So we've got a newer, bigger buffer switch, the 7280R series. It's got 4 gigs minimum in it, up to 8, and all the way up to 32 gigs on it. That 3.4, that 3 microsecond is consistent both across fiber and copper. So we're using the latest chips from Broadcom. We've got the best technology, the best software we just talked about, but it's also 25 gig ready. So as these switches actually start to enter the market, in fact, a lot of people are using this, but from a post-production perspective, they're moving to 10 gig. This is the switch to look at. You've got the 100 gig links in between. You could use those at 40 gig. You could use that at 4x25s. You could use that at 410. So each one of those QSFP 100 ports that you've got can be broken out, or you could just put a 40 gig in there if you don't need 100 gig. And some people come to me and they look at me and they go, 100 gig, really? Yes. The storage vendors we're working with, the Avid and everybody else, they're actually building out 50 and 100 gig type solution sets now. It's how to get the spindles to spin faster, or if they do all SSD. Okay. And then our product line perspective is we have the volume side, which is we were talking about with the smaller buffers, cut through switching, and then you got the store and forward big buffer switches on the right. So everything that we do in a pizza box, we also do in a chassis-based system. So you've got the big buffer systems on the right, which we'll use for most of the post houses and media production. You got the stuff on the left, which is like our commodity switch, which is equivalent to what everybody else is doing in the industry. Okay, and like I said before, it's the same bits, the same operating system, whether you're doing our pizza boxes or our chassis or even a virtual EOS. So it's the same binary image across the board. So it's not the same version of code, it literally is the same code itself. Okay. So looking at this and what we're talking about from a pragmatic perspective, and I was the IT guy or the owner of a business post-production house, about 33 cents out of every IT dollar spent is on storage. I'm spending a lot more storage because why? Because my digital intermediaries are taking up so much, but also because that's where my content is, right? What can I do with it? And how can I squeeze more out of it? So some of the vendors we're working with, some of the post-production guys are actually getting away from fiber channel because they can get more economies of scale just through Ethernet. Why do I need to upgrade from 8 or 4 to 16 or 32 gig fiber channel when I can actually get a 25 gig interface today at the cost of a 10 gig, if you will, right? That I can move towards 100 gig as storage moves to 100 gig, right? It's about the storage target. If I'm using the same switch, one Ethernet switch for everything, I get economies of scale. I also get agility, right? So how can I grow? How can I be more agile? Well, get rid of the fiber channel and go to a standard Ethernet switch. This also affords you the data protection functions, if you will, the same VLAN constructs that we've been talking about before. How do I segment off? Well, use VLAN. Why do I actually need to do different targets and LUNs from a fiber channel perspective when you could just do this all via VLANs? And it becomes more agile, and you can actually reduce the overhead and cost. Now, the Arista 4K networking consists of not only the technologies within inside the switching platform itself, but the functionality with the virtual output queues, the smart upgrades that we're talking about, the latency monitoring and telemetry information. We have some really cool, and they're free and they're used all over the place, is we have enhanced LACP hashing. So you can use more links, is what that means. Rapid automation of link loss. If you have a link that fails, we want to cut over as quickly as possible in the microseconds to cut over to another link. We also have something called distributed gateway, virtual ARP. Now instead of going up to the top where the spine happens to be to do your routing, do all the routing at the edge. You're going to get a faster east-west traffic mechanism than you would by just going to a central location. So we give you the toolkit for which to actually have a better network in a true non-blocking fashion. So we're actually trying to enable people to use these new paradigms and get away from the old way of thinking and be enabled, quite frankly, and be free. So when does the need for large buffer switches come into play? Well, so it's a matter of fact that congestion is everywhere. You're going to drop packets here or there, no matter how big the buffers are. Even if you have a 32 gig buffer switch, at some point, if you're doing line rate on every port and you're doing all these microbursts, you could drop a packet or two. So when does that occur? Well, if you look at your existing switches and you actually do a show interface or something like that, guaranteed on anything that's a storage basis, anything that's a rendering farm, and you can actually see, this is actually from one of our other, not our switches, but one of our competitor switches, is they're only doing 5.29 gigabits per second, not even full 10 gigs, and they're clocking up output discards left and right. And all we did was just go port to port on the same switch. This is because they only had, just like we had in our 7050s, 12 megabytes of buffer. So how good is a switch if you're sending packets, even from port to port, that you're actually dropping packets? Well, in our case, in the 7050, we actually have full line rate, full capabilities. We don't do this. But in the other guys, what they do is they actually build a shorter bus structure, a smaller bus structure between the chips that are front-facing. They don't have enough bandwidth between the chips that are serving the clients. And so what they have to do is they have to drop the packets. You can almost think of like two switches connected together at 100 megabits or less. Right? Maybe it's only a 10 megabit connection between the two chips, right? And you actually need 100 megabits. So they're building constraints inside the system itself. You won't see that on the front panel. You think you've got buku amount of ports, but inside the chassis itself, you're going to be dropping packets. So this is a bad thing. And we encourage people to take a look at their environment over and over to find out where those bottlenecks happen to be. And then bottlenecks also occur when you're doing speed changes, when you're going from 100 gig to 1 gig. 10 gig to 1 gig, 40 gig to 10 gig, any of those speed changes, but also when you're talking about storage. Remember I was talking about doing that advent to go from fiber channel over to network attached storage. This is where you need the big buffers because that's where everybody's talking to, or big data systems. All this ingest of packets that rush in, you need to be able to account for those, and you don't want to drop those. You don't want to put back pressure on the systems. You want to let the network absorb those. You want it to be fungible. You want it to actually be malleable and absorb those traffic congestion times to let the network do what it's supposed to do. Dropping packets is a bad thing. So if in some of our studies, and you can actually see the link here, and if this answers your question here some 40 minutes later, is we actually have white papers we do in this. Full completion time is what we care about. We care about getting point A to point B quickest as possible and not dropping the packets. You'll actually get a 50, in some cases a 60 to 1 performance improvement just by using big buffer switches. So this is true for media and broadcast. So if I was a consumer and I could buy a switch from Arista versus somebody else, and it's about the same price, why wouldn't I get an Arista switch with the bigger buffers? You'll actually get a better network. And I don't know if you could actually see the green down here. The green is us, that's the full completion time, and this is our other competitor. So they're actually taking more time, and we had to actually blow this up a bit to actually see what the scale was. But you can see us, it's very, very negligible in terms of our throughput. So we're actually very fast, and we actually deliver the packets. So that's a good thing. And then also from a broadcasting perspective, 100 gig, really? Well, if we look at the uncompressed 1080p60 standards, which are basically a 3 gigs, we call it a 3 gig stream, on a 10 gig interface, you can only get 3 streams. On a 40 gig interface, 12 streams. On a 100 gig interface, 33 streams. Well, 33 starts to become a kind of a true broadcaster, maybe a small environment, but 33 is not enough. So we're talking about a big broadcaster company, or even doing streaming, or even file transfer for that matter from a post-production, looking at 100 gig, because it is cost effective, and you can get it today, and you can actually do this at scale, then these are the things you need to start looking at. So 25 gig at the edge and 100 gig at the core. it is something, if you haven't started thinking about it, it's capable, it's enabled, and it's also cost effective to do today. So that's what people are looking at. So going back to the product line we have the volume on the left and the value on the right, okay? So I want to make sure that we're very clear on this, is you've got the smaller buffer switches on the left, you've got the big buffer switches on the right. Can you mix and match these? Absolutely. So for example, in that diagram that I showed back here, I might put the big buffer switches at the edge and then the small buffer switches in the top. Why? Because I just need fast switching at the top. In my spine, all I care about is going from point A to point B, and I should have enough buffer because it's equal cost. Down to the edge, that's where I want to have my fungible style of actually increasing and decreasing my buffer sizes. And by the way, it is dynamic buffer. We are not per port buffer. We start off with an amount of buffer on a per port basis, but we dynamically allocate that from a shared buffer perspective so that people can actually move things around. We also have our next generation 7500R. Now this sounds like a sales pitch, and maybe I shouldn't be doing this on this call because it should be not technical. But everything we're doing from a pizza box perspective, like the 7280Rs, we also do in the 7500Rs. We even took into account the economies of scale. If you could see, for example, what we can fit on a line card, you'll get 48 ports of unfettered, if you will, 10 gig copper or fiber. And then you also get a couple of 100 gig ports here because we can actually fit that on the switch itself, and we can put it on the chip. So we're going to afford you the economies of scale. And some people are actually moving away from doing 10 gig on the ports and using breakout cables. So actually using one of these ports and actually breaking out 4x10s or 4x25s. So you actually get a lower density switch, if you will, or use a lower density switch and get more ports out of it. And you're just using your cable plant to actually do that Hydra cable or that breakout cable. So you actually get a very fast, very compressed size switch, and you get more capacity out of it. In fact, you could even look at maybe even the 2RU system we have here, we call it kind of a 7502, and they use the breakout cables to actually do more with it. So you can actually get more ports and functionality out of that one switch rather than taking up a big 7 or 10 RU system. Drilling into the 7280R series, so we have the flexible 10, 40, 100 gig. Again, each one of the QSFP ports that's 100 gig can also do 40. Every one of the 40s can do 4 10s if you want. The 100 gigs can go 100, 40, 425s, 410s, so you can use breakout cables however you want. And then ultra deep buffers. Again, these could be used at the internet edge if you wanted to. So we actually do full internet route at scale for both internet edge functions and routing functionality. So it is a switch, it's a router, it's an internet edge function, it's all on the same platform. So this is why people are liking the switch. So Arista really is the foundation for media and the entertainment business. We have the time accuracy, the no drop, the automation, and we have a product that's actually built for the industry. Because if you think about what the media and entertainment industry is, it's about doing all these things at the same time. And if you do them all at the same time, you have happy customers. So we can go question and answer. Hopefully this actually hit the mark for some people and didn't get too salesy.
So I've got, what protocols do you suggest?
Good question. So if you're redoing your network, let's go back to the diagram here. Okay, so that's kind of an open question. What I suggest in the spine leaf environment here, the fastest protocol, highest convergence, most scalable is BGP. So you can use an IBGP function. It's not really that hard to do. So I would recommend that. If you're familiar with OSPF, you can do that as well. Arista uses open standards, so we don't do things like EIGRP. But it depends on what your scale is. You don't have to use BGP. I just use that because that's what we've seen from a lot of the cloud titans and what we see is the most scalable.
I've got something else here. So we have not the routing protocol, transfer protocol.
Oh, file transfer protocol type thing?
To transfer to big data.
Oh, like a big data. So there's a couple of toolkits out there. So big data itself actually has things like MapReduce functions built in. By the way, we actually have a MapReduce tracer, so we can actually see where the different applications are spinning up or spinning down, and also tracking those. That's really cool for if you're actually finding out where the bottlenecks are, buffer-wise or something else. So I just spun up these 10 MapReduce systems that are all virtual. Hey, and they all live on the same switch. Maybe I should actually stratify those across, so you can actually watch those spin up and spin down through a MapReduce tracer. And then, more importantly, we can actually see what that MapReduce function is occurring on the switch itself in terms of latency and also buffer utilization. So that's all very cool stuff. So we can also do that, by the way, for VMware. We can see as the VMs spin up or spin down, and also dynamically configure the switches. So in terms of file transfer type functions, there's a number of tools out there. If you stick with your standard FTP, you're actually kind of limiting yourself. There are cool tools if you're going site to site like Aspera, but there's also split FTP. Instead of doing a single FTP stream, you want to split up those packets into multiples, if you will. The modern systems do is they'll split the file up into multiples and then send them individually. If you think about this, is you've got a quote sliding window when you have a WAN connection. You actually want to have multiple streams happening simultaneously. Okay, so you almost want to do like a RAID array, having multiple streams. This could also get into file system structures too. So when you're talking about the file system storage, each one of the different storage vendors has a different type of file system, block or object storage, but also how they're actually monitoring the system and then maintaining what's on SSD and then getting it over to the spinning disks. So you'll see some people like Isilon, for example, who have a very fast operating system that are migrating more to a full SSD realm. Existing operating systems were built for spinning disks and where you put your inode and function. We're seeing a lot of people like StorNext, Cumulo, and Isilon build new file systems under the same name and same brand, but to do absolutely different things that are more SSD, so more built for work. Right now, we're seeing that Isilon is winning the charge on that. They're a few months ahead of some of the other guys, but all these guys are great players in this market. So that was kind of answering three different ways of the same question.
I'd love to thank Russ and Robert for presenting today on Arista. There's a lot of great information there, and if anyone wants to get follow-up information, they want to talk to someone further in more detail, you can contact me directly, melissa.duchera@GPLtech, and there's my email. You can also contact us at sales@gpltech.com. We will be putting this webinar on our website, and you'll be able to watch it at a later date, and that will be at the link below, gpltech.com/videos/#. Thank you again, Robert and Russ.
Thank you. Have a great day, everybody.
Have a great day. Bye.